This is a demo of our final year project, the ecosystem simulator. So this is me, Rohan Gomes, and Science Seal giving the demo. He is connected through Discord, and we'll be giving you the demo real time. Are you there, Science Seal?
Yes, I'm here. Hello, everyone.
Yes, so let's just begin with the overview, right? Overview of the ecosystem simulator. Why we are actually doing this project. So this is the website which you can visit to get more information about our project. And as you can see, we have clearly mentioned that there are many environmental issues and other problems which are going on in the world right now. So this project basically helps us to simulate a real-time ecosystem. At least that's what we are planning to do. And the user is just playing the role of a god, and he can actually simulate and as well as change all the factors which affect the ecosystem to his liking, and from there we'll actually be able to infer about how to prepare ourselves for the future. Do you have anything to
Right.
add, Science?
Yes. This simulation model not only helps us analyze the current scenario, but also helps us prepare for the future. As Rohan was saying, that the simulation is the model which we built was keeping in mind the actual scenario, the actual ecosystem which we have right now. So by simulating it, we can get a glimpse of the future, the direction in which the current particular species is heading towards, maybe the changes or the trends in their parameters and features, and so.
Okay, so let us get to the point by discussing the architectural diagram for our project. So this is just an overview of the proposed framework, and here you can see this is our project is basically divided into four main parts actually. This is the input, this is the simulator which we'll be discussing in details. Consider it a black box for right now, and this is the relational database, and this is the output. So will you start by describing our input framework?
Yes, sure. So the input framework, as an ecosystem needs organisms, right? So organisms, we have different kinds of organisms, or there are five different classes, the kingdoms of living beings, the five classifications. There are animal, plants, fungi, etc. So right now, for simplicity, we have implemented animal and plant kingdoms only. How do we represent organisms? The organisms are represented by me, the user or the creator, using three different files. We have a base, a current, and a modify file. The base file is what god or the user creates, assigning some values to theoretical values to features such as the base height of that species, the base weight of that species, the multipliers, etc. And the modify file, it helps the change of those particular features which we wrote in base.json generation after generation. Like
Okay.
similarly for plant also, we have base, current, and modify json. The current file, determines the current state of those features
Let's just
of the current
show the
generation.
files
Right.
for now. It will be
Yeah,
better
please.
for us. Just
So
JSON
we have
sub.
this data directory under which we have JSON, and
Let's
under
see.
the JSON folder, we have, for every kingdom we have a folder. And
Let's
could you just open? Yeah. So in the animal directory, we have two folders: the deer and the lion, the two animals which we had defined. And for every directory, for let's say the species deer, for that species we have three particular files: base, current, and modify. Now in the base file, base.json file, we can see that the theoretical maximum age of a deer is around 30 years, which the user or the god has defined, right?
yes,
And could you move over to the modified.json file,
yes, absolutely.
Rohan?
This is it.
Yes. So the modified.json file here, it records, the amount or the extent of change which a particular theoretical feature can undergo after a generation. So we can see the species max age has a value of zero point 0.1. It means there might be a 0.1% change in that particular value of species max age of deer after every generation, which is completely probabilistic, and we have left it to randomness. Yeah.
Okay, so this was
Rohan?
modified.json, and let's just show them the current.json. This is actually the won't be modified by the user. This is generated at the runtime when the progress simulation is actually running. So that's why it's right. It's in this format because the user anyway won't be editing this. I just wanted to show you all how it looks. Okay, so this was all about the input framework, and now talking about the simulator. Before we go into the simulator and outputs, let's just show you the relational database so that you will get an idea. Uh, let's just show them using the SQLite's browser. That should be better, I think.
Nice wallpaper, Rohan.
Thank you. Okay, this is the master table. These are the schema for all the tables which we have prepared. Uh, so one for
So
bamboo.
this is a huge table. Basically, we tried to store as many features as we wanted. Almost all the features of those each individual organisms present in the simulation. So we have this ecosystem master database, uh, which stores the name, kind, chromosome, generation, all the generic details of every, which is common for every living organism, and not necessarily plants or animals,
Let's just show
right?
them the
And
stats for
we
bamboo,
have,
for
yeah,
example.
yeah, this is a specific database made for the species bamboo, the plant species bamboo. Now, since this is very specific to bamboo, we have all the features represented by the columns, not just the generic ones, right? So we have average generation, then the age is the starting age of mating, the ending age of mating, the mating probability, right?
Yes.
Now,
Okay.
yeah.
So we have reached almost 5 minutes. Let's just go over the other parts a bit briskly. Uh,
Hmm.
so talking about the simulator framework itself, let's just show you a brief overview of all the classes which we are using. So let's come to the dive into the code just for some time. As you can see, our
Yeah.
code is divided into source files and header files. I'm not going into that in details. The primary class, I mean the which is present at the top of the hierarchy, is our entity dot. I mean the class entity, which is anything which is a part of the ecosystem. And we have used inheritance a in details. And if you want to read about our implementation, you can go through the doc which we have written.
Yes.
After
Yes.
entity, we have got the organism class which actually extends entity, and below that we have got the plants and the animals. Here is the plant class and our animal class is implemented here also. This was all about, I think this should be it about our simulation framework, and let's talk about the output. I don't think we have to show anything because
Yes.
we generate a lot of reports and graphs which are already uploaded in our website. You can go through
Right.
that,
Yeah.
and to wrap up the video, I think it's better to give a short demo about how our ecosystem
Absolutely.
actually works. So let's give a demo of this code which is present under random test. Let's go to the main function once. So let's just close the database just to make sure that nothing unexpected happens. So I have closed it. Let's exit from here for now. And okay, so here we have set the initial organ number of organisms to 200, and the years to simulate is 300, and we will be simulating the ecosystem for bamboo species. The rest is quite
Yeah.
self-explanatory because we are running a loop for the number of years to simulate, and for remember species it just means that we will be recording the information in a database. That's it. So
Yes, annually. We'll record it annually so that we can generate reports of based on that data later on.
okay, so let's give you a live demo. And so here we go. So on, and it's, it will go on till year 3, and these are our console logs, and these can be
And
modified.
it's interesting to note that the recent deaths and the recent births every year is quite similar, and thereby maintaining the overall population to be quite same. It's There's no sudden outburst or then sudden deaths, a large amount of deaths. It's
Yes,
quite standard.
it's quite
Yeah.
standard, and as we have also mentioned in the doc that the plant species is generally very stable in all these
Right.
things. And just let's to end, let's go through the database once for what is generated. It will be nearly the
Yeah.
same as we are not doing anything new.
Okay. Yeah.
Should be it.
Just the stats bamboo.
Stats Bamboo. Let's browse the data for Stats Bamboo. So this is there are exactly 300
Yes.
rows for 300 years, and this is the data obtained in our
Yes.
current run. And
Yes, we'll be
that's
using this data later on for generating
generating the
reports, specialized
reports.
reports.
So that's all for our project. Thank you everyone. Have a nice day.
Thank you.
Bye.